I'm going to talk to you about how Flutter handles gesture handling. First of all, let me introduce myself. My name is Guillaume, and I'm the head of Flutter engineering at BAM in Paris. You can find me on Twitter, on GitHub, and at our booth right outside. For this journey around gesture detection, we're going to talk about handling classic gestures first. Then we're going to see a little bit about how we can handle custom gestures. And for that, we're going to need to go a little deep inside Flutter's code and see how Flutter handle the gesture detection flow. Then we're going to write our own custom gesture recognizer. And finally, we're going to see how Flutter handles overlapping gesture handlers. For that, we're going to understand how hit test behaviors works in gesture and how Flutter handles gesture disambiguation. Eventually, I'll show you a little bit about how you can test all those gestures that you can implement. So let's talk about classic gesture handling quickly. When we talk about gesture handling, you all know one widget for sure is the gesture detector. The gesture detector is the higher level API for Flutter gesture detection, and it's quite convenient. It allows you to detect all the main gestures that you'd need for a mobile application. So tap, long press, double tap, and all kind of dragging on the screen. And if we look at the extensive API, you have all kind of very handy callbacks that allows you to handle most 95% of the gesture that you need on the mobile app. But you all know that, so we're not going to talk about that today. And we're going to see a little bit more about how we can handle custom gesture, that 5% of gesture that you don't know how to handle with the gesture detector. And for that, we need another widget, which is the raw gesture detector, which is the one used by the gesture detector itself. So how does this work? The raw gesture detector actually uses an interface, which is called the gesture recognizer. And the gesture recognizer is an interface that is implemented by, well, many gesture recognizer, and you can recognize the tap gesture, double tap, long press, and all the gestures I've just talked about are actually used by the gesture detector and implemented right in the Flutter code. So now, what if we want to write our own custom gesture detector? Now, to do this, we need to make a little side journey inside Flutter and understand really how Flutter works and what is the Flutter detection and recognition of gesture. So Flutter basically uses two concepts to handle gestures, and those are pointers and pointer events. So a pointer is basically a contact between your finger or stylus on a tablet or mouse on web or desktop apps and the screen. And pointer events are what describes the gesture along the way. It's the life cycle of a gesture. And it goes like this. You have a pointer added event, which is just basically saying an event, a pointer has been created and added to the list. Now you have, for example, a pointer down event saying the contact has been made with the screen. For example, if you scroll down or side scroll, you have the pointer move event for one event, two events, and several events, as long as you're dragging your finger along the screen. And then you have the pointer up event saying, okay, the contact has stopped with the screen, the pointer has been lifted, and now we remove the event and we stop tracking it along the screen. So now that we all know about those pointer and the pointer events related, let's see what Flutter does with that. When a pointer event comes in, Flutter calls, well, the entry point is the platform dispatcher, which is the entry point for any platform-related event, actually. And this one calls the gesture binding. And the gesture binding, you might know it because it's a mixin that sits at the very top of your application. And it has one particular method that we're going to use today is the handle pointer event. And that very useful method does a couple of things. So the first thing it does is propagate a hit test all through your application. And so what's a hit test? Hit testing is something performed by the render tree. And it actually consists in asking the entire widgets in your application, okay, there is a there is a pointer at that location. Who are the widgets that are interested in doing something with that at that location, with that pointer? So we ask the hit test the first widget of the tree, and we ask it, okay, are you interested? Is that pointer within your frame? So in that case, yeah, the first widget answers yes, it's in my frame. I might be doing something with it. Then it propagates through the children, and so you have two children here. One, and we ask the hit test for both of them, and one answers yes, the other one answers no, I'm not interested, this is outside of my range, I don't care about that pointer. And then we propagate to the last ones, and we have the same answer. And there you go, we have a hit test result that is the list of all widgets that answered yes to the hit test question, and that say, I might be interested in that pointer and the related events. Okay. So let's come back to our flow. Now, we have a hit test that is propagated by the render tree, and that returns a hit test result, so we know all the widgets that are interested. So we can start with the second part. The second part of this method is the dispatch event. Now we're going to go all the way through the hit test result list and ask every widget inside, well, render object inside, to call its handle event method. So this method is called on every widget, and it's actually part of the interface, hit test target interface, which says for a render object, hey, I might be interested in reacting to some user event. So this, for example, interface is implemented by a render object called the render pointer listener, which is created by some widget called the listener widget. And the listener widget is the one used by our row gesture detector that we've talked earlier. There you go. We have our row gesture detector that is implementing using gesture recognizer to render a listener and listening to all the event and registering handle event methods. So there you go. The gesture recognizer has one first responsibility is to register for any event. So basically what it does is called the add pointer and says, okay, for any event related to that pointer, I want you to call my handle event method. And it registers to the gesture binding, saying, okay, call me back for any related event to that pointer. And this is what it does. So the gesture binding will, for each incoming event, call one specific handle event, which is basically going through all the registered handle events and dispatching, delegating actually the responsibility to do something with the event to the gesture recognizer. And the gesture recognizer, that loads, okay? And the gesture recognizer has that responsibility to actually handle the event and do something with it. So now, this is the mouthful and this is the entire, but you know exactly what Flutter does when you tap on the screen and you're scrolling down the page. So this is what's happening behind the scenes. Actually, what we are going to care about is those implementation add pointer and handling the events right inside the gesture recognizer. So let's write our own gesture recognizer and see how it goes. So let's imagine I want to write an app, to create an app to help my daughter learn how to write. So we have, for example, an app where we show some letters and we're supposed to draw on the screen, and if it detects the right letters, then it says, hey, that's the right letter I was expecting. So let's skip the fact that my daughter is both too young to know how to write or to have a smartphone, and let's see how we can do this either way. So I'm going to focus on only one letter because I was writing initially this talk for Flutter Viking, so I wanted to detect the letter V, and also because it's much simpler than detecting the letter A, for example. So let's try it now. We have V-shaped gesture recognizer that is extending the gesture recognizer, and we need to override those two methods. I won't be going in details into what they do, but we are supposed to implement them. We can leave them empty, accept gesture and reject gesture. And then we dive into the core part of our gesture recognizer, and we add the add allowed pointer method. And what it does is exactly what I've shown you on the other slide, is it registers to the pointer router the handle event method saying, okay, if anything happens to that pointer, I want to know about it. Please call that handle method callback, handle event method callback. And then we implement the handle event that takes a pointer event and does anything with it. So for instance, in our case, we're gonna do something with it to track our gesture. We're gonna need some kind of tracker. I won't go into detail of how we can detect some letters because that's not the point of today, right? But we need some kind of tracker, and for every incoming event, we add the event and the pointer event to that tracker list so that it can know the shape you are drawing on the screen. And then we have some kind of has-valid shape getter that we can check if the shape is actually a V shape. And then we call back our parent saying, hey, I've detected something that looks like a V, do something with it. And that's it for our own custom gesture recognizer. We just use it, pass it through our row gesture detector in the gestures map. And don't forget to add the callback saying, okay, I want to do something with that shape. And if I can show you how things will look like. So I won't be doing any live coding because I'm too scared of that, but I'm just gonna show you the results. So if I draw an S, yeah, nothing happened. If I draw a C, nothing happened. And if I draw a V, yeah, that's detecting. And that's basically it to detect only one letter. So it works. You can write your own gesture recognizer. And I've made this Git repo, so you can check it out if you want to help me write all 25 other letters. So let's see another use case that is quite interesting when we handle gestures. Overlapping gesture handlers. Let's imagine we have a basic Flutter app. Sorry, don't see the slides. Let's imagine we have a basic Flutter app with a floating action button inside a scaffold, and we want to add some kind of layer, overlay this application that is able to detect any gestures I do on the screen without interfering with the underlying app. So that means that if I tap here, I want that button to react to my tap and do its button job, trigger some action in the app. And I want the overlaying layer to also handle the gestures and to be able to trigger some analytics event saying somebody tapped at that position on the screen. So if you do this and implement it using the stack or wrapping your gesture detector, you get that result. It means no result, actually. The transparent layer is rightfully called, but actually the button is never triggered. So this is not what we expect, right? So how do we do this? What happens when we have multiple target handler overlaying? To understand this, we need to understand what hit test behavior is. Now, hit test behavior is a property that you can pass to your gesture detection, and it has 3 types of properties: defer to child, translucent, and opaque. And these are not quite intuitive to understand because I was playing with those properties in the case before and nothing was changing. The event was never understood, captured by the underlying button. So I was thinking I must be doing something wrong and misunderstanding something from the documentation. So I went into GitHub and I found this very interesting issue called hit test behavior.opaque documentation is wrong. I figured, okay, I'm not the only one thinking that. And there is a very interesting answer from Hixie, from the Flutter team, that explains how, actually you can use a set of 3 questions for each widget to understand how they behave regarding those hit tests. And those 3 questions are the following. Let me sum it up for you. The first one is, should I pass the hit test through to my children? And for any of those hit test behavior property, the answer is yes. Any widget will always pass through the hit test widget to their children, and so that's not the issue here. Then the second question is, should I add myself to the list of widgets that were hit? So remember the hit test result before? Should I be considered as one interested, saying, hey, I'm interested in that pointer event? And so translucent and opaque property answers yes to that question, and the defer to child property, well, answers defer to child, meaning I'm gonna let my child know, respond to the hit test, and I will answer the same thing. And the third question is very interesting, is should I tell my parents that I considered the hit test to hit me or one of my children? Meaning, I'm gonna let my parents know that I am handling that event, I'm handling that hit test, and that it doesn't need to tell other children that there is a pointer at that location, and so on and so forth. And in that case, only the opaque answers always yes, but the translucent and defer to child behaves in a similar way. That means I'm gonna let my child decide what it does and do the same thing. Now you're pretty confused because you mean, okay, with that questions, they all tend to behave in kind of similar fashion. So let's see an example to understand better how this works. And I stole the example from the same answer from Hixie, so thanks again to him. Let's imagine we have a stack widget with two children, A and B container that are, well, overlapping, because it's a stack. And the B has one children, which is a circle, and has the opaque test behavior property. Now, let's see what happens when we use some different hit test behavior for the B widget. If we click right there, in the middle of our circle, there's something really interesting, because if you remember from the slide before, the B will always be either answering yes, if it's opaque, or deferring to child. So it will actually always answer the same thing as its child, circle. And so since we're hitting right in the middle of the circle answers yes to all the question, and both of them are considered hit and are added to the hit test result. But none of them, actually B is saying to the stack, okay, one of my children is being hit, I'm handling that hit test, you don't need to tell my siblings. So stack is saying, okay, somebody is taking care of that pointer, I don't need to ask A to take care of it. So A is not part of the equation, and you can see that A is never called in that case. So you are changing the behaviors, but you always get the same result, and that's weird. So what really, the difference comes when you click outside of that inner widget, inner circle. And in that case, that's interesting, because if you click outside of the circle, then the circle, even if it's opaque, is not responding true to the hit test. So what happens is that he's saying, okay, I'm not interested in that pointer, it's outside of my range. And since the B widget is in defer to child state, it's gonna say, okay, my child is not interested, neither am I. Let's leave it to another child, another of my siblings, and then A gets the actual response here. While you could expect B to respond. Then in the opaque case, it's the same thing. C is still not touched, but B is gonna say, okay, I'm taking care of that hit test, just leave it to me. And only in the translucent case, B is gonna say, I'm interested, but let anybody behind me know that, that there is a pointer event at that location. And so in that case, both of them answers. And there you have all the differences. As well, I will show you the link at the end, but there is this hit testing page I created on a GitHub repo. So if you want to try it out, and if you forgot about what I've just shown you and want to play with by yourself, please check out the GitHub repo and play it and see by yourself how it works. Okay, so now you've seen that in most cases we have two or several widgets responding to the same event. So who is actually going to handle that event? Now, to understand this, there's a concept written in the documentation of Flutter, which is called disambiguation. And this calls one very cool named component with the gesture arena. And what the gesture arena does is it takes all widgets from the hit test result and ask them, well, actually they all register to the arena from the gesture recognizer and say, okay, I want to be barred in that arena, and then everybody's gonna fight in that arena, and only one winner, the first one that calls resolve, is gonna say, I'm handling that gesture, all the other ones, you can go home, and then the arena is gonna say, okay, I reject all the other ones. So this concept is very important because it's partly why wrapping the gesture detector earlier didn't work. And if you want to know more about this, there's this great video from Craig on decoding Flutter, who's explaining exactly what you need to understand about the gesture arena. So be sure to check it out. I'll put the link at the end again. Okay, so we've seen where the problem comes from. So what do we do? How do we solve this? And how? Because I still want to have my stacked widget be able to respond to my gesture. So to do that, I need to go a little deeper under the raw gesture detector and use what's called a listener widget that we've seen on the other slide. And the listener widget is right there behind the raw gesture detector. And again, I will call my friend Hixie with his great explanation about what the difference between a gesture detector and a listener is that listener will always report pointer that it sees, while gesture detector will fight in an arena and only one gesture per pointer can win the gesture. So there you go. You have the main difference between those two is the gesture detector fights in the arena and you have only one winner, while the listener is more conciliant and you are able to handle directly the pointer events, and then you can have win-win for any widgets. And here is our solution. So let's see how it looks. The listener widget is very low-level API. You are directly handling callbacks, handling pointer events, and you can use the behavior to change the hit test behavior as you understood from the previous slide. There you go. We have a scaffold. Let's wrap it not in the gesture detector, but rather in a listener. We pass our pointer callbacks, and we can handle from this low-level API all our pointer events, and that's good. Our on-press button is still called, and we can see it as an example. If I drag my finger on the screen, it's actually called back, and here both the button and the overlying gesture detector are called. So yeah, challenge resolved, right? Okay. Final thing, how we can test all the gestures. So we've seen how to implement our own custom gesture recognizer to be able to detect and recognize any kind of gesture. We've seen how we can disambiguate overlying gesture detection and make them react to the same gestures. To test this, there's this awesome widget tester API that holds everything you need. It has a very high-level API to test widgets, to simulate gestures. So for example, if you wrap a gesture detector or any of your implementation and pump that widget, then you can call the tap method or any other method to simulate those high-level gestures that you know of from the gesture detector. And you can just verify the callback has been called, and it's very easy to use. And you have all that higher tap, long pressing, dragging on the screen, flinging, which is kind of fast dragging. And you can both call that on specific widgets with finders, or using at precise location to say I want to make a tap at that specific position regardless of what's underneath in my application. There you go, you have that high-level API, and you can also create your test gesture that you can move around with a little more granularity, and you can call some down and move method. So just the same way you're gonna write your own test and you're gonna create a test gesture, start gesture will call the down event. So this will generate actual pointer events in the binding behind. Then you can move the gesture along the screen, and then you call up, and it's called the pointer event up. So you can really see with that kind of API how we can test all all letters of the alphabet from our application and make a whole very test-covered application. Yeah, there you go. We verified that all our callbacks are being called for each moving gestures. So we have a high-level API, a lower-level API, and all of this is calling the test widget Flutter binding. So the actual implementation that we've shown earlier is the one used behind in the testing environment. So everything you've written that is working on your application will also work in your test, and that's a good thing. So no matter which implementation you use, we've talked about the gesture detector, the raw gesture detector, and the listener. It will always be testable with that same API, and that's really convenient. So to wrap all things up, let me summarize a little bit. We can detect most usual gestures using the gesture detector. If we need to recognize some specific gestures, we can go a little deeper and use our raw gesture detector by implementing our custom gesture recognizer. If we need to handle multiple gestures that are simultaneously working and overlapping, then we might need to go even deeper and use directly the listener, which will handle the pointer event low-level API. And we can test all of those implementation very easily with the widget tester API that is very convenient. Here are some useful links for you if you need. Be sure to check out the gesture binding and gesture disambiguation documentation from flutter.dev. Craig's video, it's only 8 minutes and you understand everything about the gesture arena. That's awesome. Be sure to scroll down the thread of this issue about how OPEC documentation is actually not so wrong, but misunderstood. And be sure to check out the GitHub repo I've made. It's really messy, but it's a sandbox. If you ever bump into some gesture-related issue, just clone the repo and play with it on your computer. And yeah, reach out for any questions so we can discuss this on Slack or Twitter or whatever. Thank you for having me. And if you have any question that we don't have time to answer, please reach out on my Twitter account or Slack or wherever, or at our booth outside, and I'll be happy to discuss gestures and more about Flutter. Thanks.